In this video, I'd like to show you how to use these definitions of sine, cosine, and tangent in these ratios, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, to find the sine, cosine, and tangent of the angles in a right triangle. So here are two right triangles. We're going to describe the sine and cosine, and we can also find tangents as well of the angles in this right triangle. So in this right triangle are ST, the sides are 6, 8, and 10. I'd like to find these quantities. So I'm going to find the cosine of angle R. So we'll write as cosine R. We're going to find the sine of angle R. We're going to find the cosine of angle S and the sine of angle S. And then maybe at the bottom we'll also find the tangent, just because we can, of angle R and the tangent of angle S. Note that I don't care about t. On 90 degree, we almost never bother finding the tangent or sine or cosine of 90-degree angles. We only really care about these for the acute angles that are in the right triangles. So from angle R's perspective, the leg that's adjacent to angle R is this side that's 6, and the hypotenuse of this triangle is 10. So cosine angle R is 6 over 10, or reduce that, how about the 3 over 5? The sine of angle R, sine is opposite over hypotenuse, so the sine of angle R is 8 over 10, which is 4 out of 5. Switch gears. From angle S's perspective now, cosine is the adjacent leg over hypotenuse. Now from angle S's perspective, the adjacent leg is now 8. So from angle S's perspective, the cosine of angle S is the adjacent leg, which is now 8, over the hypotenuse, which is still 10, which is 4/5. And sine, now the leg that's opposite of angle S now is 6, and the hypotenuse is still 10, or reduce this to 3/5. You may notice some kind of interesting things that are the same, like the sine of R is the same as the cosine of S, and the sine of S is the same as the cosine of R. This is not a coincidence. This is there's some real deep connections between sines and cosines that you'll notice along the way, and you're going to study even more in future classes like Algebra 2. Finally, it didn't ask us in the directions to do this, but we'll do it anyways. What is the tangent of an angle? How about the tangent of angle R? From angle R's perspective, the tangent is, well, in any event, tangent is opposite over adjacent. And from angle R's perspective, the side that's opposite of it is 8, and the leg adjacent is 6. So I think the tangent of angle R is 8 over 6, or maybe 4/3. And from S's perspective, the opposite leg is 6, and the adjacent leg is 8. So 6/8 or 3/4. 4/3. Okay. Play the same game over here. We'll find the sine, cosine, and we'll throw in tangent. Why not? I think of each of these two acute angles. So just as before, how about the sine of R and the cosine of R? And how about the tangent of R? Let's see, the sine of R, opposite over hypotenuse. From R's perspective, the side opposite of it is 12, and the hypotenuse is 13. From R's perspective, the adjacent leg is 5, and the hypotenuse is 13. And from R's perspective, the opposite leg is 12, and the adjacent leg is 5. Similarly, the sine of S, the cosine of S, and the tangent of S. From S's perspective now, the opposite leg is 5, and the hypotenuse is 13. From S's perspective, the adjacent leg is 12, and the hypotenuse is 13. And from S's perspective, the opposite leg is 5, and the adjacent leg is 12.